Good evening, all. Welcome to the day 3 session of the FDP program, Ethereum blockchain and creating smart contracts by Mr. Lohith JJ. So this is Dr. Gautami. I am introducing Mr. Lohith JJ. Mr. Lohith JJ received the BE degree in Computer Science and Engineering and MTech degree in Computer Network and Engineering from MITU University, Karnataka, India in 2008 and 2008 respectively. Currently pursuing a PhD degree in Computer Science and Engineering from NIT Trichy. In 2011, he joined the Department of Computer Science and Engineering, BMS College of Engineering as a lecturer, and in 2012 became an assistant professor. He has 5 years of research experience in the field of blockchain technology. He is having 17 years of teaching experience. He has published many conference and journal papers in national and international conference journals. He has served as a resource person in the area of blockchain in more than 25 FDPs sponsored by AICT and Atal workshops conducted across India. And his research interests are in blockchain, cryptography, cryptology, computer networks, and network security. And expanded information about our today's speaker. He has published a textbook in data communications for fourth semester BCA, Bangalore University, and he has delivered several guest lectures in Krupanidhi Degree College, and he is a life member of CSI, ISTE, CRST, and he has served as a research person in the field of blockchain technology in national conferences and BSCT in 2019. And he is an expert and research person, research speaker in many Atal FDPs and many more FDPs conducted by so many universities. And he has a lots of experience in the area of blockchain and technology. Now, welcome you, sir, for our FDP to enlighten us in the area of Ethereum blockchain and creating smart contracts. Thank you, sir. Thank you. I'm welcoming you, and I'm hand over the session to you, sir.
Thank you, man. Thank you for introducing myself to the participants. Okay. So, good evening, everyone.
Good evening, sir.
So, basically, I just want to know what is your background knowledge in blockchain? What do you know about your blockchain concept has been explained, Bitcoin, cryptocurrency has been explained, right? So, should I start with teaching theory, Ethereum concept, or directly start with teaching smart contract and hands-on session? So, this information I required from the participants. Madam, you are muted.
Sir, you have to start it with Bitcoin, after that Ethereum, after that creating smart contracts.
They are aware of blockchain technology?
Yeah, sir. Yeah, because we have one optional subject is there in our AC in R19 regulation.
Mm.
So that's why some of the faculty are also aware about the blockchain. And some hackathons will also be conducted in our college in blockchain technology with the support of Idea Labs, future technologies like that in Hyderabad.
Then I'll directly start with Ethereum blockchain.
Yeah, okay, sir.
Fine. Okay. So I hope that my screen is visible.
Yes, sir, visible.
Okay, so coming back to the Ethereum blockchain, as you all know that, so in the year 2008, there was a white paper published on Bitcoin, okay, by anonymous speaker Satoshi Nakamoto. So prior to that, also blockchain technology was developed, but based on this white paper, right, blockchain was pretty famous. Okay, so blockchain 1.0, blockchain 2.0. Blockchain 1.0 was useful only for financial transactions like a Bitcoin, whereas blockchain 2.0, right? So they started using this blockchain for Ethereum, right? In which Ethereum is a decentralized platform which runs smart contract, right? In which case the application that run exactly as programmed without any possibility of downtime, censorship, fraud, or third-party interference. So as you all know that blockchain is a decentralized public ledger, which in which you store, when you store the data in the blockchain, they are immutable. So by making these functionalities, okay, this they have developed using this blockchain technology, and they started using smart contract, which was developed in 1995 by Nick Szabo, right? Using the combination of smart contract and blockchain technology, Ethereum blockchain has been developed by one of the founders, right? So blockchain 1.0 was mainly dedicated for Bitcoin transactions, whereas the blockchain 2.0, so they started using Ethereum. So in Bitcoin, the transactions are only financial transactions, right? Sending one coin from one sender to other receiver. Okay. So now, what is the prerequisite to be part of the blockchain network? Do you have any? Do you have any address? Is address is required, participants? So I require kind of interaction here, so that it gives me an opportunity to deliver whatever it is not. It is required. Okay. So participants, what is the concept of Bitcoin? Because everyone knows that Bitcoin is just blockchain technology, right? So Bitcoin is dedicated only for financial transactions. Okay, whereas Ethereum is behind that, not only financial transactions, other than that, financial transactions like data transfer, storing data is also considered as a transaction in terms of Ethereum, right? So here in Ethereum, right? So Ethereum is more than cryptocurrency. So I think you can see this history of Ethereum. So he is the one who co-founded Ethereum when he was 19 years old, and he is none other than Vitalik Buterin. So he's the person who co-founded Ethereum when he was 19 years, right? So Vitalik Buterin became involved with cryptocurrency early in its inception, right? So when 2008 and 9, when Bitcoin was incepted, right? So he involved himself in this cryptocurrency, co-founding Bitcoin magazine in 2011. So in 2014, he launched Ethereum. So Ethereum, and when you deploy that Ethereum in a blockchain, right? So Ethereum also started using smart contracts, right? So blockchain 2.0, Ethereum blockchain. So this is the most popular blockchain for developing smart contracts. As you all know that blockchain is categorized into public blockchain and private blockchain. So can you give an example for public blockchain, participants? Can you give an example for public blockchain? Anyone? Public blockchain, private blockchain. Any answers? I request participants to interact here so that I'll get an idea whether you are aware of the concepts or not. Any answers, participants? Public blockchain, private blockchain. Public blockchain is a Bitcoin and Ethereum are the examples of public blockchain, whereas private blockchain means, for example, Hyperledger Fabric is completely a private blockchain. Getting here? Okay. So Ethereum is the most powerful, popular blockchain for developing smart contracts. So what is a smart contract? I'll come across that in detail. So Ethereum is a public or private blockchain with a built-in Turing complete language to allow writing any smart contract. Right? Ethereum is mainly public, but you can also create like a private blockchain with a built-in Turing complete language. What do you mean by built-in Turing complete language? What do you mean by Turing complete language? Any answers? Yes, participants, kindly answer, or whatever you know, just give that information. I assume that participants are not active here. The participants are not active. The what are the FDP that is conducting? It is not of so use.
Sir, actually, they have muted, all are muted, sir. That's
Let
why
them
they are.
post in chat, ma'am.
Yeah, okay. Okay, sir.
Because I just want the clarity. So whether they are aware of those concepts or not. That's it. Okay. Right. So here, built-in Turing complete language is nothing but you can give solution for any of the problem. Turing complete language is nothing but which provides solution for any of the given problem, and so that you can write the smart contract. So Ethereum virtual machine, I think everyone are aware of Java virtual machine, JVM. The same way we have Ethereum virtual machine which can execute scripts using an international network of public nodes. So in JVM, you know that when Java program is compiled, it creates a bytecode, and these bytecode can when they are compiled, then when they are interpreted, it can execute that, right? In the same way, EVM also does the same thing. The smart contracts, once they are compiled, it creates a bytecode. Okay, so under Ethereum, Ether is a cryptocurrency in Ethereum network. For example, in Bitcoin, BTC is the Bitcoin coin, right? In the same way, in Ethereum, Ether is a cryptocurrency. Next, so you know that blockchain is a fully distributed database like Bitcoin. Okay, advantages is highly secure, transparent, and immutable. What do you mean by immutable? Why blockchain is immutable? Any answers? What do you mean by immutable? The special functionality of a blockchain. Functionalities makes the data that is stored in blockchain is immutable. Yes, participants. Any answers? Answers. See, you're all faculties, right? You have to interact here.
Sir, some are given in the question and answers. Question and
Okay.
answers window.
I'm not getting any.
Changeable. They are given. Some are answered.
I'm not getting any chat messages. Okay, fine. No one got.
Your window is not sharing. Your PPT is not sharing, sir.
Now only I think someone has made me a co-host, so everything is changed now.
And now you can see messages also, I guess.
Yes.
Okay.
Yeah, now I'm able to see that. Okay, fine. Okay, I'm not shared the screen, right? Okay, is my screen visible now?
Sir.
Okay, fine. Now, what do you mean by immutable? The data, once it is stored in a blockchain, it is immutable. That means data is permanent. You cannot modify the data once it is stored in blockchain. What makes this to be permanent? So the cryptographic primitive concept like hash functions, as hash functions are used, and these hash pointers are linked from one block to another block. So they are making the data to be stored permanently, because if you try to modify any data, so from that block onwards, you should keep on modifying all the blocks of data till the current block, which is highly impossible. Right? That's what the pros of. Are you aware of the concept mining here? Friends, you know about mining?
Sir, your PPT is not sharing.
No, I've shared the screen.
We
Now?
are not. Yes, sir.
Yeah, no, I'm shifting that from PPT to current screen. I'm just viewing any participant is sending any message or like that. Okay. Are you aware of the concept of mining? Participants? What do you mean by mining? Coins will extract from machines. Okay. So how exactly mining happens? Right? I'll just show you one diagram. So can you all see this blockchain demo? Now, you know that for every unique, for every data, you get a unique hash. For example, now I'll add data, and you can see here, hash values are changing, right? If you change data, again, hash values are changing. So that is what the concept of hash function, which is one-way function, right? Now we will see block. What is a block? How does a block looks like? So block will have block number and a field called as nonce, data, and hash. What do you call this hash? This hash is called as the
PPT.
yes,
PPT
madam.
is not sharing, sir.
Blockchain demo is not visible.
No, sir. Your PPT is not visible.
Not PPT, ma'am. I'm giving some demo here.
Only,
Blockchain demo. Huh?
only audio.
Okay, let me share. Madam.
Yes, sir.
Blockchain demo you can see, right? Okay. Now this is what the block information. You have a block number, okay, nonce value, data, and hash. So what is the hash value here? What do you mean by difficulty target hash? Anyone? The difficulty target hash is set so that the person who mines, he has to generate this difficulty target hash. So what do you mean by difficulty target hash here is, so this hash value has to start with first 4 zeros, right? So what is the concept of mining here is, it is simple that you have to solve a puzzle. Okay, what is that puzzle now? For example, this random number is not given here, but there is a difficulty target hash that is provided. Okay, for example, so when you find the hash of the entire block, so your target hash should be starting with first 4 zeros, right? Now this hash is broadcasted and everyone knows that what is the difficulty target hash. Now a person has to mine that block in such a way that when he generates the random number and find the hash of that, so this generated hash should be equal to target hash. So what is the target hash here? It should start with first 4 zeros, right? So this generating that random number is, right, you have to use an algorithm. For example, if the random number is 1, see, some hash is generated, 12 some value, 123 some other value, 1234 some other value, so 12,345 some other value, but first value is starting with 0. Then I will add one more, no, so like this you keep on trying with random number, right? One particular time when the random number 72608 is generated, automatically you get a hash. So here mining is happening just here. See, when the random number is 72608, at that time the hash generated is equal to target hash. So this indicates that the block is successfully mined. Getting here? Is this clear, participants? Participants, is this clear? Any doubts here? I can proceed, right? This is what the process of mining, right? So in blockchain, you have a block of, see, block number 1, block number 2, block number 3. Okay. So in block number 1, so there is a value field called as previous hash. So initially, what do you call the first block? What do you call the first block? Any answers? Friends? Any answers? Genesis plug. How to fix? Okay, I'm seeing some question here. How to fix nonce? See, here nonce is nothing but a random number. So you have to keep on generating that random number at one particular time when, see, because, okay, I'll just show you one example here. Simulator, I'll just show you. It's a trial and error method. Okay. Now, Bitcoin simulator.tk. So here you can, I'll show you that how exactly you can do the mining. Now, see here, can you see this? This block 3291, right? This was done in my last week FDP. So I allowed the participants to do the simulation wherein they involve in mining. Okay. Now I'll do one transaction. There are some pool of transactions here. Okay, can you see here? Memory pool of transaction. Okay. Here, for example, none we sent to Sheetal is one transaction. I'll verify this transaction and I'll add this to block. Okay, insufficient balance, add anyway. Now I'll start mining now. Okay, carefully observe this. I'll enable this mining. Okay, can you see here? For every random number, it is generating unique hash. At one particular time, right, when the random number is generated and when the generated hash is equal to target hash, mining will stop. Getting here? So this, for example, this is the random number that is generated. That is how you can generate the nonce. Getting here? Participants? Some of you have asked question how to fix that none. So this is how, right? The value of nonce is generated based on the target hash. Yes, Bitcoin is the cryptocurrency. Yes. Bitcoin is the first cryptocurrency. Any doubts? Yes, here trial and error is doing automatically, right? Yes. Automatically it keeps on generating random numbers. Okay. At one particular time, when the random number, see, for every random number that is generated, you can see here in this simulator, it is generating the hash. See here, for every random number, it is generating hash value. So when the generated hash is equal to target hash, it stops mining. So that indicates that successfully it has mined that particular block. Is it clear? Friends, any doubts here? If the doubt is clear, Ramesh Babu? Yes. Okay. So this is how mining and concepts of mining is involved. Now, in Ethereum also, see, Ethereum is also same like blockchain, highly secure, transparent, and immutable. The disadvantage is scaling and performance issue. Okay. So Ethereum blockchain consists of three elements: transaction list, block header, and owner list. So what is transaction list? Is nothing but what is a transaction? What is a transaction? For example, in Bitcoin, what is a transaction? Answers: sending coin from one account, one wallet address to another wallet address is considered one transaction in Bitcoin, right? So this Ethereum consists of this transaction list. And is there any limit on the number of transactions that can be stored in a blockchain or block? Participants, is there any limit? No. So you can store any number of transactions, right? And what is the value that is stored in the block with reference to transactions? Suppose if there are some 10 transactions, right? So what value is stored in a block? Hash value, yes. Hash value of all the 10 transactions, or what? Hash value of previous, no, not exactly. See, there are some 10 transactions. What information about the transaction is stored? You know the concept of Merkle tree? Is Merkle tree concept has been thought? Okay. So when in the leaf node of the Merkle tree, all the transactions are stored, right? So you combine the transaction and form a hash value like this, right? You have a root hash. So this root hash is nothing but this hash of that block. So here block consists of three elements: transaction list, block header, and owner list. Owner list is nothing but list of all uncle blocks included. That means, right? So when the transactions are added to the block and the block is not mined, so that is nothing but that uncle block. So Ethereum blockchain is also looks like Bitcoin, right? So this information you can see in this etherscan.io. Etherscan.io is a website wherein you get all the information about the Ethereum blockchain. You know what is the current block size? Currently, see 1,69,33,145 is the current block number in Ethereum blockchain, which was mined some 10 seconds ago. Okay, and in that block there are 172 transactions that are accepted in 12 seconds, and 0.09476 is the Ethereum ether that is rewarded. Getting here? So you know that the node which successfully mines will be rewarded, right? So these were the live Ethereum blockchain information. I'll just refresh this, right? So you'll get some more blocks added. Here, it's already 150. So by the time that I'm explaining here, so 5 more blocks are added. Getting here? Are you able to understand this? Any doubts? Eligibility to become miner. Any node can become miner provided they should have a highly configured devices. For example, there are many companies who are working like a mining companies. What's the purpose of working? Because they will be rewarded, right? So a node which successfully mines will be rewarded. For that reward, right, many companies are working like a mining companies. Anyone can become a miner. For that, you should have a highly configured devices and you should download the entire blockchain to your device. So only when you are having an existing blockchain in your device, you can be part of the miner. Highly configured means can you give the configuration? So this configuration, right? Because see, it all depends on the network, right? See, for example, in the Bitcoin network, right, it consumes a lot of energy. Suppose if you are mining in Bitcoin network, per month your bill will be around more than 1 lakh. That is how the energy consumption that it incurs when you try to mine, right? In Ethereum, it will be less. So there are many other networks like Polygon, okay, which works in layer 1 and layer 2 also. Depending on that, right? So you require a suitable configured devices. Like normal devices, you cannot use it for a miner. Getting? No, you can't work in your regular machines. Okay. So Ethereum blockchain, all blocks will be visible like Bitcoin. However, blocks have a different structure than Bitcoin. So blocks faster than Bitcoin and reward is different. Every 12 seconds, blocks are generated. But now we are seeing that every 3 seconds also blocks are generated. This was the old scenario, right? Earlier, in the initial stages, 5 Ethereum is rewarded. You know what's the price of 1 Ethereum? Currently, what is the price of 1 Ethereum? Answer? Right? It is available in ethereumscan.io or in any of the exchanges. You can see that currently it is around 1.5 lakh, 1 ether. Okay. Earlier, 5 ethers were was given as a reward, but now it is 0.7 or 0.9 because you have more number of miners, right? Anyone can become a miner, right? So that is why many people are participating like a miner because of that rewarded amount. So that is why the rewarded amount is also decreased. The Ethereum nodes validate all transactions and new blocks, and it operates in a P2P fashion. What do you mean by P2P? How exactly the nodes, the information that is broadcasted, right? How exactly it will reach the nodes? Any answers? Yeah, what do you mean peer-to-peer? So when a transaction is broadcasted, how exactly this transaction is broadcasted? That means the node which is transacting, it will send the transaction to its next peer node. Then that node will send that to its peer. Like this. It is not that you flood that. Broadcasting in terms of networking, broadcasting means you keep on sending that, right? No. Here, broadcasting is taking place in terms of peer-to-peer. All transactions and new blocks operate in a peer-to-peer fashion. Each contains copy of the entire blockchain, right? And this implemented in a variety of languages like Go language, Rust, Solidity, like this. Till now, you have any doubts in blockchain now? I'll just give some 2 minutes time now, right? So if you have any doubts, you can answer. You can ask the questions. If you have any doubts in blockchain, you can ask, so that I will clear your doubts and continue further. Participants, if anyone wants, you can interact, you can ask questions. See, I have started working in blockchain from 2017 till now, right? So I have developed nearly some more than 10 projects, right? More than 5 publications. Okay, I have guided more than 10 projects, right? So I worked on Ethereum smart contracts only. Ethereum smart contract is my research area, right? So any doubts in blockchain as of now? Can you proceed further? Participants? How to work on blockchain if you don't have high configured machines? Which language is used in blockchain? Okay, to work on blockchain, right? So you have various private blockchains, you have various test networks, right? For highly configured machines, if you want to join a public blockchain, which is having crores of blocks, right? You require that, but you can create your own blockchain network, right? I'll demonstrate that now, right? How to deploy that smart contracts in blockchain. Virtually you can deploy, or you can create a local blockchain in your, you can download that in your device, or you can use the test networks. That is what the hands-on session that I'll be discussing now. Which language is used in blockchain, right? Go language, Rust, right? And the smart contracts which we deploy, they're all written in object-oriented. Can we work with Java in blockchain? Yes. You can create a blockchain network using Java also. Yes, it is possible. Any other doubts? Thank you for interacting here. I'm very happy. Any other doubts? Whatever you have doubts in blockchain, you can ask that. Proceed further. Is blockchain hacked? See, blockchain cannot be hacked because it is completely secured, right? The transactions which are sent in blockchain are transparent, but not about the wallet, because all the wallet address that you use in blockchain, right? They are all anonymous. Nobody knows that who is the person who is using that particular address. You doesn't get anything by hacking a blockchain. It's a decentralized distributed database wherein you use it blockchain network to store the data, and every node who is part of that blockchain will be having the copy of the entire blockchain. For example, I showed you on etherscan.io, right? 1,69 lakhs. If you want to be part of that Ethereum public blockchain, then you have to download the existing blockchain. But you can create your own blockchain network, or you can use the test networks. That's what I'll be demonstrating now. Is it clear? Any other doubts? Friends, shall I proceed further? Say yes or no. Okay, assuming that, so no questions, I'll proceed further. Okay. So how exactly? See, blockchain is a technology. Please understand here. Blockchain is a technology, whereas Bitcoin is a cryptocurrency, and Ether is a cryptocurrency which uses blockchain technology to store the data. Don't get confused or don't misunderstand the concepts. Blockchain is a technology in which these cryptocurrencies, they use blockchain technology to store all kind of transactions. Is this clear? Right? For example, in the Bitcoin network, right, every node is uniquely identified by a wallet address. Right? But nobody knows that who is the person who is using that wallet address. Anonymity. Because of this anonymous, right? So government has banned using of the cryptocurrency in India. You cannot use cryptocurrency in India. You can only invest or trade. Do you know this? Participants? Okay. In the same way, in Ethereum, you have two different types of addresses. Whereas in Bitcoin, you have only one type of address, that is wallet address. Whereas in Ethereum, you have two different types of addresses. Which are those addresses? One is external owned account, like public wallet address. Other one is contract account. So what is this contract account? What do you mean by smart contract? Anyone? Any answers? What do you mean by smart contract? Any answers? Participant, what is a smart contract? In general, smart contract is nothing but a program which is written to avoid a third party, like a digital contract. For example, now, right, everyone are aware of tenant and owner agreements, right? Physical agreement, right? They're all, you have to do that notary for that. So physically, you will do everything. But if you use a smart contract is nothing but a simple program. It's a program, right? So when you write a smart contract, in which case, right, these smart contracts are deployed in blockchain. So once these smart contracts are deployed, they are stored permanently. So you create a smart contract for any of the problem. For example, tenants and owner concept is there, right? For that, I'll create a smart contract, in which case, right? So the smart contract is written indicating that this is what the advance amount that tenant has to pay, and on and before of every month, right, tenant has to pay so and so rent. So all these informations are available in that contract. I'll deploy this. My tenant will again deploy that contract, and automatically on and before of every month's 10th, automatically he can transfer the rent to my account. For this, right? So to specify all this information, you'll create a smart contract. Getting here? Is this clear? Participants, clear about smart contracts? So when the smart contracts are deployed, they're all stored in blockchain. That is where, right, you know, blockchain, right? So once the transactions are stored in blockchain, they are immutable. So Ethereum has made use of this blockchain to deploy all the smart contracts, and they're all stored in blockchain. Getting here? Any doubts here? Participants? Doubts? Is this clear? Shall I proceed further? Fine. So in Ethereum, you have two types of accounts. One is general wallet address. Other one is when this smart contracts are deployed, so it generates a contract address. That is what the second address. So one is general wallet address, other one is the contract address. And these addresses consist of public or private key pair. And this allows for the interaction with the blockchain. So what does that external account consist of? Externally owned account is nothing but the normal wallet address in which it identifies the user, right? So there, this external account has a associated nums, associated random number, code hash like root hash, and storage root is the root hash of Merkle Patricia tree. Okay, for example, in contract account, right, you have all this information, nuns, code hash, okay, storage root. Other than this, you have a smart contract code also which is deployed. Whereas the externally owned account doesn't have that. It has only the parameters like nuns, externally hash code, storage root hash. All this information will be available. Is this clear? Any doubts here? Any doubts? Private key and public key. See, private key, Ethereum private keys are 66 character strings with 0x appended, which indicates that represented in hexadecimal, right? So whereas the wallet address looks like this 0x A6 FA 5A like this. So what are transactions in Ethereum? As I told you in Bitcoin, the transactions in Bitcoin is nothing but transferring or sending cryptocurrency, that is Bitcoin, from one wallet address to another wallet address is the Bitcoin. But whereas in Ethereum, it is behind cryptocurrency, right? So a request to modify the state of the blockchain is also considered as one transaction. Okay, deploying smart contracts is considered as one transaction. Changing the state of global state of that is considered as a transaction, right? So when these are all the different transactions that can be performed. So when you send a transaction, so this transaction will be signed using private key of that original the sender account. Okay, so the different types of transactions are sending value from one account to another account, creating smart contract, executing smart contract code. These are all considered as transactions. Okay, is this clear? Any doubts here? Okay, meanwhile, I'll just give this information. Please download this so that we can have handstand session. Suit.com. From this website, download Ganesh for Windows. Can you see my chat messages? Participants? I don't know whether my chat message has received or not. Respond here. Did you all check my chat message? Not getting my chat messages. I can see that people are sending chat messages, but I'm not able to see. Okay, please download that, Ganesh. Yes, one person has raised. And Dasari Vijay. Madam, can you please allow this person to interact with me?
Okay, sir.
Or else I'll only talk. Hello, yeah. Yes, sir. Dasari Vijay, you can interact.
Madhu, sir.
Dasri Vijay, you can unmute and interact here.
Madhu sir, please give permission.
Yes, Dasari Vijay, you want to interact here? Okay, fine. Next, in Ethereum, you have different denominations. Ether denomination, WEI, lowest denomination, right? So Jabo is the next denomination, which is named after Nick Jabo, right? Finney is the second highest denomination. So this is named after Hal Finney, who received the first transaction from Nakamoto, who is the anonymous author of Bitcoin white paper. Right. So code execution, every node contains a virtual machine similar to Java called the Ethereum virtual machine and compiles code from high-level language to bytecode. As I told you that the smart contract is once it is written, right? Once you compile the smart contract, it generates a bytecode. And these execute smart contract code and broadcast the state to the entire network. Is it clear? Now, I hope everyone have downloaded, are trying to download. Okay. Now, I'll teach you how to write a smart contract. Okay. Now, please be ready with your desktop or laptop so that I'll be giving the instructions and you can follow that. For example, here, open this remix.ethereum.org. remix.ethereum.org. Paste in the chat. I'm not getting any chat messages. It is not updated for me. I don't know why. Okay. Can you all open that remix.ethereum.org? All working with me? Now, remix.ethereum.org is a platform, web browser platform, which allows you to, which is acting like an IDE for all smart contracts that you develop. Okay, you use this to develop a smart contracts. Okay, so on the left side you can see, right, home, then below that file explorer, then below that Solidity compiler, then deploy and run transactions. So I'll click on this home. Okay, and there are some built-in transactions or built-in contracts that are available. You can just use those contracts. For example, I'll just open storage.sol. So this is what the simple contract. Can you all see the contract here? Can you all see the smart contract here? You can also open the same contract. Go to remix.ethereum.org, right? Then click on the contracts. So same contract will be opened for you also. Can you all do this? Friends? open that smart contract. Shastri, okay. Yes, people have to interact here, or else I will not be knowing whether you are able to follow that or not.
Sir, one more time repeat that one, sir.
Madam?
One more time you have to repeat that one. Remix
Please
we are going to
open that remix.ethereum.org.
yes, sir. Open it.
Okay. Then on the left side you can see home, files,
Okay.
Solidity compiler, then deploy and run transactions.
Okay.
Okay. And there you have contracts.
Contracts are there.
Just click on that contracts. Below that you can see one_storage.sol.
Honor and ballot solutions.
Okay, just select that one_storage.sol. You get a contract like this. This is a simple contract, smart contract.
Okay, sir.
Able to follow, right? Okay. So pragma solidity greater than or equal to 0.8.2, lesser than 0.9.0. This indicates that pragma is actually like a header file, indicating that the below code is a solidity code which has to be compiled in the version above than 0.8.2 and lesser than 0.9.0. Is this clear? Next, contract storage. Contract is a keyword, right? Storage is the contract name. So this is written in Solidity programming language. For a smart contract, smart contracts are executable codes, Turing complete, and it functions like an Excel account, which can hold funds, which can interact with other accounts and smart contracts, and these contracts contain the code, and this can be called through transactions. These smart contracts can be called through transactions. Okay, so initially, these are what traditional contracts looks like, right? You have a paper, you have to write down that in the paper, then it has to be audited, notarization has to be done, then it has to be executed. Whereas in a smart contract, right, you have a write a program, it is a software program, you have to write the program, right? You don't require audit because once these contracts are deployed, they are stored in blockchain, which are all immutable. Anyone can see that, right? So you don't require audit, right? So execute that. So once you deploy that, you get a byte code that is generated. So once you execute that, right, automatically your contracts are executed, right? So this is what here you can see here, smart contract which is developed by Nick Jabo in 1994, right? The simple program wherein users use the smart contract to send the money or to send the data to that contract code also. So when these contracts are deployed, they are stored in the block, and these blocks, once it is mined, they're all stored like a blockchain. Getting here? Is this clear? Any doubts here, participants? See if you have any doubts. Participants? Any doubts? Are you able to follow this?
Sir.
Smart contract has any utility, sir? What do you mean by utility? Say, you can write smart contract for any of the, I told you that tenant and owner example, right? Okay, like this, for that is why it is a Turing complete language, indicating that you can write solution or you can write smart contract for any of the problem. Is it clear? Right? So this is a very important concept. Smart contracts. Writing smart contracts is very, very important concept. For example, in Ethereum smart contract, using Ethereum smart contract, you can develop DApps, decentralized applications, DApps. Okay, so you can give different kinds of problems to your students to develop the DApps. So whatever hands-on session that I'm delivering now, right? If you correctly follow that, so you can demonstrate all this information to your students. Or else, right? My videos are available in YouTube, right? I'll just show you that videos. I'll paste that information also in the chat box so that you can go through those videos. Okay, so this is what I'll paste this in the chat box. So if you go to this, you get my videos. Clear? Right? Many of my videos are available in which hands-on session are also explained here. You can see here, day 3, session 1, Mr. Lohith, hands-on Ethereum smart contract. Right? Lohith JJ, hands-on Ethereum smart contract, day 2, session 2. Like this, plenty of videos are available. You can go through those videos. Is that clear? So, smart contracts, right? So all these contracts are called through transactions, and once these smart contracts are deployed, they are immutable. And how will you write the smart contract is the programming language that is used to write the smart contract is Solidity. Solidity is an object-oriented, contract-oriented, high-level language for implementing smart contracts. Right? So if you are familiar with object-oriented, right, it is very easy to learn the smart contracts, which is written in Solidity. Okay, so this is one simple contract example, right? Contract counter, int private count is equal to 0, function increment counter public count is equal to count plus 1, function decrement counter public count is equal to count minus 1, function get count. So this is a smart contract which allows you to increment the counter and decrement the counter. Then based on that, right, it allows you to get the count of that information, right? Now, in the same way, you can see one smart contract here, pragma solidity, contract storage, unsigned into fix, which is a data type, and number is a variable. Okay. So here you are using some two functions, function store and function retrieve. Right. So function store, in which it receives the unsigned into physics number as a input, and that is stored in the variable number. So store is a function which you use it to store that number in the variable. In the same way, you can see another function, function retrieve. Function retrieve, public view returns return number. Retrieve is a function which retrieves the value from a variable. So when you execute the smart contract, you can provide the value to a number variable, and what is the value that you assign to a number, you are able to retrieve that number or value from that number. Getting here? This is what the usage of the simple smart contract. Is this clear? Any doubts here? Now I'll demonstrate you how to use compile the smart contracts and deploy it. Clear, participants? Are you all working with me? This is a very important stage. Once you are familiar with this, you can ask your students to implement different contracts. Right? Okay. Now, how to compile this? Okay, on the left side, can you see Solidity compiler? On the Solidity compiler, and you can see compiler version 0.8.18. If this is allowed, if this version is allowed, because I have specified in the program that pragma solidity greater than or equal to 0.8.2, less than 0.9.0. So 0.8.18 is the compiler that is allowed. Okay, and compile one underscore storage dot SOL. .SOL indicates that this is a solidity file. Okay, now I'll try to compile this. I'll click on this, compile one underscore storage dot SOL. Can you see that? Once the contract is compiled, right? So it has created a contract storage one storage underscore SOL. Okay, below that you have publish on IPFS, publish on SWAM, and compilation detail, and ABI and bytecode. I'll copy this bytecode and try to paste this in Notepad so that you can view that. The bytecode that is generated for the contract. Then the same way, application binary interface ABI. So once the contract is generated, it creates ABI. I'll copy this and paste this to the Notepad so that you can. This is what the application binary interface. From user interface, if you want to communicate with the smart contract, then you have to create a. Then you have to use this application binary interface and integrate this with web3.js. Okay, React.js is used to create a front end. So when you use web3.js and when you try to integrate this application binary interface to web3.js, right, it allows you to interact from the user the smart contract. Is this clear? Participants, are you all working with me? Now we have compiled this successfully. Now we'll try to deploy this. So below the Solidity compiler, you can find deploy and run transactions. Select this. Once you click on that, then you can see environment, Remix VM, and below that account, then gas limit, value, deploy, at address, transaction recorded. Can you all see this? Participants?
Yes,
Any
sir.
doubts still here? Which IDE we used to write program in Solidity? You can use this remix.ethereum.org, which is very simple version to acting like a browser enabled IDE to write all smart contracts. Virtual Studio also you can use. The action is .SOL. Clear? Any doubts? Any doubts, participants? Proceed further. Any doubts? Domain.io means what is domain? Where you come across this domain.io? Mean by this domain.io? Where do you come across that? See, once you open that, directly click on that. You have a contracts, right? Click on that contracts. For example, I'll close this and open once again. Now I'll open this etherscan.io. See, this is a website. This is a website which you will find real-time Ethereum blockchain information. Clear, right? Current block about what is the current block, what is the current market price of an Ethereum, all right? What is the transaction, and what is the transaction that is stored in every block? All these informations are available in etherscan.io. Is that clear? So that is different. Now whatever I am teaching, that is different now. Again, I'll open once again now Ethereum dot remix dot. So please see this remix dot Ethereum dot org. Click on this and select, open that remix Ethereum. Taking time. Okay. Now, as soon as you click on this, automatically you get a platform like this. Then there you can see contracts. Open that contract directly. Storage.sol. Is this clear? Right? Now we have to compile this. So you have a Solidity compiler. Okay. Compile this. Successfully compiled. Then it has created a bytecode. Below that, you have deploy and run transactions. There you can see this IDE. So there you have environment, account, everything. Okay. So I'll just copy and paste this account. Can you all see this? Ethereum allows two different types of account, right? This one account, which is called as externally owned account or wallet address. Is that clear? You can also find that right in Remix. How many are working? Can you able to identify that address right? Friends, any doubts here? Right. So now you have seen this externally owned account, right? So it has created some, because environment, you have Remix virtual machine. So this is a virtual environment in which virtually all the transactions are stored. Then I'll show you the local blockchain also. Okay. Then you have a gas limit. What is gas? So gas is an internal currency in Ethereum. Gas is an internal currency in Ethereum. For example, now I have a small question which everyone will be answering. Okay. Suppose now yes, we can use Solidity. Yeah, see, every network, they use some different languages, right? Okay. So Polygon may use some different language. But where you are deploying that is important. You are not going to use don't use public blockchain. Please understand, don't use public blockchain. Okay. So you have to use some test networks. Polygon network, then BSC also is another blockchain, right? So gas is nothing but an internal currency. Okay. Or for every transaction that you send, it consumes some kind of gas. So I have a simple question here. Suppose now, if your program, when you're writing C or C+ program, if it encounters infinite loop, so what will you do? How will you overcome that? If any program encounters infinite loop, how will you overcome that? Participants? Answers? How will you overcome if you have any try catch mechanism in Java? Okay, fine. Next. But here, once the smart contract is deployed, you cannot modify that, right? So once your contract has such kind of infinite computations, because, right? So it is difficult to control that, because this contract is already deployed in blockchain and you cannot modify that, right? So to overcome that, right? So we use a gas which is acting like a halting problem. So you can use cannot tell whether or not a program will run infinitely from compiled code. So to overcome that, right, you charge fees per computational step to limit infinite loops and stop plot code from executing. So when you charge fees for every computation step that is involved in the smart contract, okay, so at one particular time, even though it incurs infinite loop, so all your wallet will drain out by paying this computational step, so that at one particular time you can break the execution. Getting here? So for that you use gas as a internal currency in Ethereum, and every transaction needs to be specified an estimate of the amount of gas it will spend, and essentially a measure of how much one is willing to spend on a transaction. So if at all, if you are creating a transaction, you have to specify how much you will be willing to spend on the transaction. How you specify is, so you get the gas price. So gas price information is available in Ethereum gasstation.info, right? So when you're deploying a smart contract, you have to specify this: what is the gas limit, maximum amount of gas the owner is willing to spend. Okay, so you have to calculate the gas cost. Gas cost is calculated by gas limit into gas price, right? So the same thing you can see here, gas limit. So you are specifying the gas limit for this program, okay, and value in WAI, right? So as this is just a simulation, so I will not use any of the value for the WI. WI is a lowest denomination in Ethereum, okay. And below that you can see deploy or at address transaction recorded. Right now, if I click on this deploy, automatically the contract is deployed and one transaction will be recorded. Okay, can you see this? Now I'll try to deploy this. Now I deployed this transaction and you can see transaction recorded. How many transactions are recorded? Participants, can you all see this? Transactions recorded. One. Yes. So deploying a transaction is deploying smart contract is considered as one transaction. Okay. Now, as soon as you deploy this transaction, a contract address is created, right? Can you see here? Transaction record is equal to 1 and deployed contract. So I'll just copy this contract address and paste that so that you'll get information about that. So this is how the contract address. So in Ethereum, I told you that you have two types of accounts. One is externally owned account, other is contract account. So this is what the first one is, the externally owned account or the wallet address. The second one is the contract address. So as soon as you deploy the contract, right, for every contract that is deployed, it creates a contract address. Is this clear? Any doubts here, participants? Any doubts? Yes, Ramesh Babu K. You can interact. Ramesh Babu?
Audible?
Yeah.
Yeah. So here, what is the difference between EVM and JVM? Usually, JVM will work as an interpreter, which converts the bytecode into machine language, binary code. So,
Yes.
can you define the difference between the Ethereum virtual machine, Java virtual machine?
See, Ethereum virtual machine also, right? What are the smart contracts that you're deploying, right? Once the contracts are compiled, it generates a bytecode, right? I have shown you that, right? So here, can you see here? When I compile that code, it has generated bytecode. I'll copy this bytecode and paste it again, once again in the notepad. Like this, bytecode is generated. So EVM also in all these things is done in Ethereum virtual machine, that is EVM. Okay. Now, once it is compiled, Now I'll deploy this, execute this smart contract. Like in the Java, you compile that and interpret that, right? But in smart contract, you compile and deploy that smart contract so that your contracts are stored in blockchain. All these things are done in EVM, Ethereum Virtual Machine. Is this clear?
Yeah, means here EVM is acting as a compiler.
You have a Solidity compiler, right? So compiling the code and converting that high-level language to bytecode is performed in Ethereum Virtual Machine.
Okay, actually JVM work will start from bytecode. So JVM will convert bytecode to binary code. So it means these two are different, right? As far as the functionality is concerned.
Yes.
Thank you. Thank you.
Yeah. Any other doubts, participants? You're able to do hands-on session, right? Okay. Now I've deployed this transaction record is equal to 1, and I've shown you how exactly the contract address is also generated. Now I'll expand this storage at right. So can you see this? Store and retrieve. What are the store and retrieve? Can everyone able to understand here? Store and retrieve. Into the what is the use of the store and retrieve? The store and retrieve are functions which you have defined in the smart contract. Okay. Now, store is a function which is used to store the input that is considered from the user in the variable, whereas retrieve is a function which retrieves that value. Now, please observe my screen now. I'll give some value, 1000. Okay. Now, I'll deploy, I will click on the store, right? Now, as soon as I click on this, it is considered one transaction. Can you see this? What is the transaction recorded now? Friends? 2, right? So, as soon as the state, so whenever you're doing any transaction in which the state of that global data is changing, that is considered one transaction. Now, I'll click on retrieve. Will it consider as one transaction? I'll click on retrieve. Will it be considered as one transaction? The answer for this. Click on retrieve. Does it consider as one transaction? Answers. Spends. No answers. No clarity. One. No, it is not considered one transaction. Why? Why? Because you're just retrieving the value. So global state is not changing in Ethereum. State of that is not changing, right? So it is not considered as one transaction. So if I retrieve, it will display 100, sorry, 1000. You can see here, right? It's clear. But now all transactions are done, right? Now we have deployed a transaction, they are stored in blockchain. But where are those transactions? So environment that I have used is virtual machine. Virtually, it has stored all those transactions. And now, see, can you see this in the account? What is the balance? Initially, it was 100 Ether. Now, can you see what is the balance here? What is the balance amount? Participants? It has consumed some ethers as a transaction fees. That is why you have the balance as 99.9999. Is this clear? Right? The next level is, so we have to download a local blockchain Ganesh. Right? As everyone downloaded Ganesh? Participants? Has everyone downloaded Ganesh? People who want to learn, please download that Ganesh. I'll give 5 minutes time. Kindly download that.
Sir, we can't hear.
No, I just gave time so that people will download that Ganesh. Everyone downloaded Ganesh? At least people who are involved in hands-on. Can you just tell me whether you're still downloading? Taking time. That's yes, that's why. I'll give some 5 minutes time. Well, if you have any doubts, you can ask me in Bitcoin, cryptocurrency, or Ethereum, or blockchain, anything. Because see, working on smart contract is very, very important, and you have a very good research opportunities here. I am currently working on vulnerabilities in smart contracts. Okay, so all my 3 research papers are worked on vulnerabilities in smart contracts. There are some tools which is able to detect those vulnerabilities. For example, ONT, Mythril, Smart Check. Okay, so some of my students, they have extended that existing tool, right? So I have also proposed a solution how to detect vulnerabilities in smart contract using machine learning approach. So you have plenty of opportunities to work on this. name to be downloaded. Ganesh from trufflesuit.com. Trufflesuit.com. From here, you have to download Ganesh. 1.0 Bitcoin, 2.0. What is the latest tech? Latest, I think, blockchain 3.0. Everyone are aware of Web 3.0, right? In which case, Web 3.0 is suitable for virtual reality, right? So Ethereum currently it is using blockchain 2.0, right? So blockchain 3.0 it to come. Nodes in cryptocurrency, blockchain, mining. You know what is that mining procedure? It is called as proof of work. Consensus algorithm. Under consensus algorithm, you have proof of work, proof of stake, proof of elapsed time, like this, right? So whatever the puzzle mechanism that I have discussed, it is termed as proof of work. Okay. So what is proof of stake? Yes, I'll be discussing that proof of stake now. So that puzzle concept is called as proof of work. For that, in terms of proof of work, there are many number of miners who will be participating, and every miner will be consuming lot of energy, right? For example, China, right? So China says that whatever the energy that it is consuming for mining, right, it is more sufficient for Pakistan. This is what the statement that is given by China. China is very much involved in this mining. So proof of work involves that, whereas proof of stake. So in terms of proof of stake, right, every miner has to deposit amount. Every miner has to deposit the amount in an escrow account. Escrow account is nothing but a third valid account. So if at all, if you want to be a miner, you deposit some amount, right? More the stake, more the opportunity. For example, now I want to participate like a miner. I deposit 1 lakh. Some other people will deposit 50,000, someone 5,000, someone 10,000, someone will deposit 5 lakhs. Okay. Now, person who has deposited 5 lakh will be given an opportunity as a miner. The more escrow you post, the higher the probability you will be chosen to nominate the next block. So if you nominate a block with invalid transactions, you lose your escrow money. This is also very important. Now, just because that I have given an opportunity of mining, if I try to invalidate the transaction, which is valid, or if I validate the invalid transaction, I lose the amount that I have deposited in escrow account. This is what the concept of proof of stake. Currently, Ethereum is moving to proof of stake from proof of work. Clear? What's about this? Proof of work and proof of stake. Any notes here? So I'll just demonstrate this remaining part. Okay. So Ethereum. So now I hope everyone have downloaded Ganesh. Let me open that. I've already downloaded and kept. Okay, I'll open this Ganesh, which is a local blockchain to your device. Because we have used the environment remix virtual machine, right? So we are not getting the feel of the transactions, whether the transactions are stored in blockchain or not, right? So as I have downloaded that Ganesh, all these transactions, I'll try to connect this remix with Ganesh. All the transactions automatically it will store that in Ganesh, right? Now I'll use another wallet, MetaMask. So you can get that metamask.io. I'll give this information in the chat. metamask.io. Okay, so you can download this as a browser extension. MetaMask IO. Just open that metamask.io. Download for Chrome. So I've already downloaded as a browser extension, which is available, but you can click on this add to Chrome. Okay. Once you add to Chrome, it will ask you to create an account. I'll just open that now. Okay. Now I've already added that to the browser extension. I'll open that MetaMask. So while you created that account, so okay, it will ask you to password. You please provide that password. So whenever you open this, it will ask you the password. Okay, fine. Now I have opened MetaMask. MetaMask is acting like a private wallet. MetaMask is acting like a private wallet. So whenever you're doing any transactions in Remix, right? So these transactions will be validated by this MetaMask. Now Ganesh also it is opened. So once you install that Ganesh, it will open this. You click on the quick start, and defaultly it provides you 10 accounts, wherein each account is having 100 ether. These are all dummy ethers. Okay, I'll open this Ganesh now. My system is a bit slow. Please bear with me. What the procedure that I'll do is, see, MetaMask is there, right? And in the MetaMask account, you will not have sufficient balance. Okay. So when you click on that MetaMask, you get Ethereum main network. If you want to choose Ethereum main network, which is a real-time public network, so better not to deploy the transactions in Ethereum public network. Okay. So then you have different test networks, Goerli test network, Sepolia and Linea. And then you have localhost 8545, right? So there, this localhost 8545, you have to connect this to local Ganesh. Okay. Now let me see whether you can see here. So once you open this Ganesh, it will create an 100 account, 10 accounts where each account is having 100 ether, and you have accounts, blocks. Here, Genesis block is created for you. So once you open that Ganesh, already one block 0, that is Genesis block, is mined at exactly 747. Okay, transactions as of now, no transactions. Right. So there, you can change the settings also. So come to this settings, and you can change the settings. So here, port number should be 8545, so that we can connect that MetaMask to this. I think everyone's port number will be 7545. Kindly change that port number to 8545 and restart that. Okay. Then you can see that RPC server address, it should be 127.0.0.1 and 8545, so that I can connect that MetaMask to this. Okay. Now in this here under this, there are different networks, right? I will select localhost 8545. Okay, so now it is connected to localhost. That means MetaMask and Ganesh are connected now. Okay, but here I am having two accounts wherein these two accounts balance is 0. Right. For that purpose, what I will do is I'll try to import an account from Ganesh wherein that account is having 100 ether, right? So how to import? Click on this circle, then there is an option called import account. Click on this, and it is asking private key here. Now come back to Ganesh, right? Accounts. So there, this address at the last column, you can see show keys. Click on the show keys. You get a private key. Copy this private key. This done. Come back to MetaMask. Paste that private key here. Control V and import. Here, the account 3, right? The same account 0x8FC, which was there in Ganesh, it is imported to MetaMask because this account is having 100 ether. Okay. Now what I'll do is I'll try to connect this MetaMask with Remix. Okay. This account. So you can see I'm not connected. I'll click on this. So I'll connect this account 3. Click on this connect. Automatically, it will be connected now. You can see here, this account is connected, right? Okay. Now for a better, I'll refresh this Remix now. So my Remix is connected to MetaMask. MetaMask is connected to localhost Ganesh, and we have imported one account from that Ganesh. Now I'll deploy the same smart contract. Show that in the Ganesh. Show the transaction. Now I'll compile this. Successfully compiled. I'll deploy this. Okay. So in the deployment, you have to change the environment to injected Web3 or injected provider. So when you click on this environment, you get different environment. So injected provider, I'll select this, and once I select, automatically MetaMask will be active. So you can see that here, injected provider. So as it is already connected, so you can see 0x8FC with 100 ether. So you got this. Now I'll deploy these transactions. Please observe here, as soon as I deploy, MetaMask asks to verify the transaction, confirm the transaction. So MetaMask is acting like a wallet address. So what are the transactions that I'm performing here? I'm signing the transaction using my wallet. Now I'll click on this deploy. See here, MetaMask is active. Can you all see this? And it is asking me to confirm. See here, estimated gas fees, total. So only if I confirm, then the transaction is recorded. So can you see this? Transaction recorded. Now I'll come back to Ganesh and I'll show you this transaction. See here, block 1, just mined now 752, right? Gas use 1 transaction, and I'll see I'm showing this transaction also from address 0x8FC, created contracted address, right? So transaction is stored in this local blockchain and blocks are also created. Is it clear now? Any doubts here? If you already have MetaMask, you can just log into that, right? Okay. Now we'll open the session for question and answers. Are you able to understand this mechanism? Hands-on session and deploying the smart contracts. Any doubts here? You can raise hands to interact so that allow you to interact here. Participate, any doubts? The hands-on session. I have shared my YouTube video link also. You can go through. All these information is available in that video also. You can do step by step there by watching that video. Any doubts here? Participants? Okay. Thank you for brief explanation with clarity. Yes, thank you. Welcome. It's my pleasure. This is my 29th FDP session throughout India. Right? So let me know if you have any queries. You can contact me. I'll give my mail ID, lohithjj@gmail.com. For any kind of collaboration work, you can contact me. Let me know if anyone is having any kind of doubt. There are no queries, right? I'll stop the session here. I hope you have gained some knowledge about this hands-on session, right? I'd like to thank the organization for providing an opportunity to share my knowledge.
Thank you, sir. Thank you for a brief introduction and hands-on session on Ethereum and creating the smart contracts, deployment of contracts, and executing the contracts, and storage, retrievals, and a local blockchain of Ganeshi. And MetaMask.io, we are importing from MetaMask to Ethereum and all these things. We are given a hands-on session also. We have a clear idea, and thank you for giving this opportunity for us. And we will plan to work with you on Ethereum and blockchain platforms.